Hello everyone, in this video I am going to explain mechanics IAL exercise 4a. In the previous video, which is based on the same 4a, I explained what is the force diagram and how to draw them, what are the different kinds of forces. So today we will be implementing that knowledge in order to solve our questions. So here is our first set of questions. A box is rest on a horizontal table. Draw the force diagram to show all the forces acting on the box. So let's say this is a horizontal table and there is a box resting on it. So this is the box. Now this box is in contact with the table, so there will be contact forces and there is a normal reaction. But first the weight of this box will be going downwards, so that force is, let's say, W, and there will be an equal and opposite reaction on the opposite side, that is perpendicular to this horizontal table. This force is R. You can show it with N also, the reaction, because the box is at rest, there is no motion, so both of these forces, they must be equal. Then we have the second question. Trapeze bar is suspended motionless, that means there is no motion, from the ceiling by the two ropes. Trapeze bar is basically a kind of horizontal bar, and this kind of bar is used in the hospitals for the person and for the patient who are not able to move a lot. So in that case they use it to make the movements. So this is suspended motionless from the ceiling by two ropes. So let's say this is the first rope and this is the second rope. Obviously there will be some weight of this bar and that will be acting downwards, and this weight, because the trapeze bar is suspended motionless, so it is balanced by the tension in the ropes. There will be tension force in the ropes, and that is shown by the letter T. Then next we have, ignoring the air resistance, draw the diagram to show the forces that are acting on a particle acting on an apple as it falls from the tree. So in that case, this is question 3. So there is an apple and it is falling freely without any air resistance. So it is falling from the tree. When it is falling from the tree, so there will be a weight here. That force will be acting on this object, and that is W. Then we have a car's engine applies a force which is parallel to the surface of a horizontal road. So it is parallel to the horizontal road. So let's say this is a horizontal road and a car is here. Now the car's engine is applying a force parallel to the horizontal road that causes the car to move with a constant velocity. Constant velocity means there is no acceleration, and the object is moving like this way. Let's say this is the driving force. You can show it with a P or F, whatever letter you want to use. Consider the resistance to the motion, because it is the horizontal road is given and they said there is a resistance to motion. The resistance to motion is always on the opposite direction of the motion. So let's say that force is F. Other than these two, there will be the weight of this car which is acting downwards, and because car is in the contact with the horizontal surface of the road, so there will be a normal reaction which is perpendicular, and that is shown by the R. Now these were the 4 questions. Now the next set of question is, given that each of the particle is stationary, means there is no movement, work out the value of P. Now if you see the first part in 8a, there are two forces acting, and because the object is not moving, so if we see in the vertical direction, the P force, that must be equal to 10 Newton. For the second question, we have the forces in the horizontal direction as well as vertical direction, and object is stationary, so we see on the vertical direction both the forces are equal, and same should be for the case of horizontal direction forces. So P should be equal to 30 newtons because the forces are balanced as the object is stationary. Then we have third case. Here we have the one is vertical set of forces which are equal, and because the object is stationary, the particle is stationary, so the horizontal forces should also be equal. So the two forces are in the right direction, which is P and 1.5 P, so we will add them up to find the forces in the right direction, that must be equal to the forces in the left direction, which is 50 N, because the object is stationary. So this is 2.5 P, and that is equal to 50 newtons, and P is equal to 50 divided by 2.5, or we can solve it. So it is gonna be 20. So P is equal to 20 newtons. So this is the question 8. Now we have the next question here, and the next question is question number 9. In this question we have given a diagram here, and in this diagram they said ignoring the air resistance and work out the tension T in each of the rope. The tension in each rope is okay. There is a first part. So there is a tension in the rope. So we know that the forces are balanced because it's constant velocity. It's written constant velocity. Constant velocity means there is no acceleration. No acceleration means no force, because force is equal to mass times acceleration. So that means T plus T, that is 2T, it must be equal to 400 newtons. So T will be equal to 200 newtons. Now they say the tension in each rope is reduced by 50. So if the tension is reduced by 50, so that means the tension in each of the rope will be 150 and 150 newtons, and this is going in the upward direction, and the force acting in the downward direction was 400. So now the forces are not balanced. In the upward direction there is 300 force in total, and in the downward direction there is a force of 400. So now there is not constant velocity, there is a different force. So if there is a different force, there is an acceleration. So the object will be moving downwards, and the resultant force in the downward direction will be 100 newtons. Now the next question comes up here. Question 10. The diagram shows a particle acted on by a set of forces given that the particle is at rest. If the particle is at, the forces will be balanced. So if I talk about the horizontal forces first, so P will be equal to 50 Newton. And then in the vertical direction we have 5Q, and that should be equal to 3P plus Q plus 10. So it will be 4Q is equal to 3P plus 10. I brought this Q to the other side. So now we have 4Q is equal to 3P. So 4Q is equal to 3P means 3 times 50, which is 150, plus 10. So 4Q is equal to 160, and we can say Q is equal to 40 newtons. So we find the values of both P and Q. Then we have our next question, which is question number 11. In question 11, what we have given is, again the particle in the diagram is moving with a constant velocity, so there is no net force. So we can say horizontal forces will be equal. So 2P plus Q is equal to 25, and second equation is 3P minus 2Q is equal to 20 newtons. I multiply this equation by 2 so that we will have the coefficients of 2 as like positive and negative 2, and we can cancel them by adding the two equations. So I multiply this equation by 2 now. So I will get 4P plus 2Q plus is equal to 50, and second is 3P minus 2Q is equal to 20. When I will add these two equations, so I will get 7P is equal to 70. So that will give me P is equal to 10. Now I can substitute this value of P in this equation 2 or 1, that's up to you. One of these two equations. So 3 times 10 minus 2Q is equal to 20. So 30 minus 2Q is equal to 20. 30 minus 20 is equal to 2Q. So 2Q is equal to 10, and that gives me Q is equal to 5, and these are the forces, so 5 newtons and 10 newtons. So this was all about exercise 4A. Thank you.